In this video, we will learn the Rolle's theorem. Michael Rolle was a French mathematician, and in honor of him, this is called Rolle's theorem. The statement of Rolle's theorem is, statement let f be defined, let the function f be defined on the bounded interval AB if f has a local maximum, if f has a local maximum at a point x0 in AB, and if a prime exists, if first derivative exists, then a prime of x0 is 0. So, this is the statement of Rolle's theorem. That means graphically, if you think, so this is x-axis, this is y-axis. Suppose you have a function, this is f of x. So, this function is y equals to f of x, and this point is a, this point is b. Then it says there is a point x0 here where maximum occurs. So, at this point x0, so at this x0 the slope is 0. So, a prime of x0 is 0. At this point the slope of the function is 0 because first derivative means slope. So, at this point the slope is 0. Now, we need to prove this theorem. So, to prove it, suppose the function f has a local maximum, at a point x0 in AB, then for delta greater than 0, we have a less than x0 minus delta less than x0 less than x0 plus delta less than b. So, if this point is x0 and delta is a positive number, then suppose this is x0 minus delta and this point is x0 plus delta. So, a less than x0 minus delta, which is less than x0, and x0 is less than x0 plus delta, and x0 plus delta is more than b, less than b. Now, if we think only, now if we take a point, suppose here, if we take a point T here, like if x0 minus delta less than t less than x0. So we take a point t in this interval from x0 minus delta to x0, x0 minus delta to x0. Then f of x0 minus f of t minus f of x0 over t minus x0 would be more than or equals to 0. Why this is more than or equals to 0? Because this t, f of t is suppose here and f of x0 is here. So f of t minus f of x0 would be a negative number. The numerator is a negative number because f of ft is less than f of x0. So this is a negative number, and t minus x0 also a negative number. So both are negative number, therefore the conclusion would be positive, and if they are same point then it would be 0. Now if you take the limit, that is limit of, and if the function t is constant then it would be 0. Then if you take limit, then t approaches x, f of t minus f of x0 over t minus x0 would be, this is more than or equals to 0, that is f prime of x0 is more than or equals to 0. Okay. Now if you take a point, if you consider a point t here, so now we are considering t in the interval from x0 to x0 plus delta. So if x0 less than t less than x0 plus delta, then f of t minus f of x0 over t minus x0. So in this case f of t is suppose here and f of x0 is here. So f of t minus f of x0 would be negative. So numerator would be negative. How about denominator? So t minus x0, so t is here on the right side of x0, so t minus x0 would be positive. So numerator is negative, denominator is positive, so the result would be less than. So this is less than, and if the function is constant then it would be 0. Now if you take the limit, that is limit of t approaches x0, f of t minus f of x0 over t minus x0 is less than or equals to 0. This implies f prime of x0 is less than or equals to 0. So at x0 first derivative is more than or equals to 0, again first derivative is less than or equals to 0. So if you combine this one and that one, then we can conclude that by, therefore f prime of x0 is 0. So this concludes the proof. This completes the proof. Thanks for watching.